More planets in the universe could potentially support life than there are people on Earth. Yeah, let that sink in for a moment. With the vastness of the cosmos and the mind-boggling number of galaxies, stars, and planets out there, the odds of finding habitable worlds are staggering. It's a humbling thought, isn't it, that we might not be alone in this cosmic ocean. The search for habitable planets and extraterrestrial life is one of the most exciting frontiers in modern science. These are worlds that could potentially support life as we know it, with the right conditions for liquid water, a breathable atmosphere, and a stable climate. And thanks to powerful telescopes and cutting-edge techniques, we're discovering more and more of these tantalizing candidates all the time. But what exactly makes a planet habitable? What are the key ingredients for life to thrive? And how do we go about detecting signs of life on these distant worlds? That's what we're going to explore in this video. While the idea of discovering habitable planets is incredibly exciting, the reality of exploring these distant worlds presents some formidable challenges. The first and most obvious hurdle is the sheer vastness of space. Even the closest potentially habitable exoplanet, Proxima Centauri, b, is over 4 light-years away. To put that into perspective, if we could travel at the speed of the fastest spacecraft ever built, it would still take us tens of thousands of years to get there. The distances involved are mind-boggling and pose a significant barrier to direct exploration. Another major challenge is our current technological limitations. Our telescopes, while powerful, can only provide so much information about these distant planets. We can detect their size, mass, and sometimes even their atmospheric composition, but getting detailed images or sending probes to these planets is beyond our current capabilities. The technology required to travel such vast distances or to build telescopes with the necessary resolution is still in the realm of science fiction. Moreover, even if we could overcome the distance and technological barriers, there are other practical issues to consider. For instance, the harsh conditions of space travel, such as cosmic radiation and the need for sustainable life support systems, present significant risks to any potential missions. Additionally, the time it would take to travel to these planets means that any mission would likely span multiple generations, raising ethical and logistical questions about the feasibility of such endeavors. Let's dive into the key characteristics that scientists look for when determining if a planet could support life. Distance from the star. First and foremost, the distance of a planet from its star is crucial. This is often referred to as the habitable zone or the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist on the planet's surface. For instance, Earth sits comfortably in the Sun's habitable zone, allowing for the presence of liquid water, which is essential for life as we know it. However, this zone varies depending on the type of star. Smaller, dimmer stars like red dwarfs have much narrower habitable zones, and planets within these zones are often subjected to intense radiation, which can strip away their atmospheres and make them less hospitable. Presence of water. Water is another critical factor. It's the solvent in which life's biochemical reactions occur, and it's necessary for transporting nutrients and waste within organisms. Planets with stable long-term sources of liquid water are prime candidates for habitability. Earth, with its vast oceans, rivers, and lakes, is a perfect example. Other celestial bodies, like Jupiter's moon Europa, are also intriguing because they may harbor subsurface oceans beneath their icy crusts, potentially providing environments where life could exist. Potential for life. Beyond just water, a planet needs the right conditions to support life. This includes a stable atmosphere that can trap heat, shield the surface from harmful radiation, and provide essential chemicals like nitrogen and carbon dioxide. The planet's size and gravity must be sufficient to hold on to this atmosphere. Additionally, The presence of energy sources such as sunlight or chemical energy from hydrothermal vents is vital for sustaining metabolic processes. Planets also need a way to recycle nutrients, which can be facilitated by geological activity like plate tectonics or volcanic eruptions. Other factors that contribute to a planet's habitability include its magnetic field, which protects the surface from solar and cosmic radiation, and its rotational and orbital stability, which ensures a consistent climate. For example, Earth's magnetic field, generated by its molten outer core, plays a crucial role in shielding life from harmful solar winds. Similarly, Earth's relatively stable orbit and axial tilt help maintain a climate that can support diverse ecosystems. While the search for habitable planets is fraught with challenges, understanding these key characteristics helps scientists narrow down the vast number of exoplanets to those most likely to support life. Gliese 12b, the nearest temperate rocky world. The discovery of Gliese 12b, just 40 light-years away, is particularly exciting. This rocky exoplanet, about the size of Earth, orbits within the habitable zone of its cool red dwarf star. With an estimated surface temperature of 42 degrees Celsius, 107 degrees Fahrenheit, Gliese 12b could potentially support liquid water, a key ingredient for life as we know it. What makes Gliese 12b truly remarkable is its proximity to Earth. At just 40 light-years away, it is the nearest temperate Earth-sized exoplanet discovered to date. This proximity opens up the tantalizing possibility of studying its atmosphere in detail using powerful telescopes, like the James Webb Space Telescope. By analyzing the atmospheric composition of Gliese 12b, scientists hope to unravel clues about its potential habitability and even search for biosignatures, molecules associated with biological processes that could indicate the presence of life. Kepler 1649c, an Earth-sized world in the habitable zone. Another groundbreaking discovery is Kepler 1649c, an Earth-sized exoplanet orbiting within the habitable zone of its star, located about 300 light-years away. While more distant than Gliese 12b, Kepler 1649c's size and orbital position make it an intriguing target for future atmospheric studies. Detecting biosignatures on Kepler 1649c would be a monumental achievement, potentially providing the first evidence of life beyond our solar system. However, even if no biosignatures are found, studying the atmospheric composition of such a distant, Earth-like world would yield invaluable insights into the formation and evolution of potentially habitable planets. Implications for the search for alien life. These discoveries represent a significant milestone in our quest to find inhabited worlds. For the first time, we have identified nearby, Earth-sized exoplanets that could potentially support life, opening new avenues for exploration and study. By analyzing the atmospheres of these worlds, we may finally be able to answer the age-old question: are we alone in the universe? Even if no definitive signs of life are found, the mere existence of these habitable exoplanets would profoundly impact our understanding of the prevalence of life in the cosmos. Moreover, these discoveries pave the way for future missions and telescopes specifically designed to study the atmospheres of Earth-like exoplanets, bringing us closer to the goal of finding and characterizing inhabited worlds beyond our solar system. As we continue to unravel the mysteries of these tantalizing exoplanets, we inch closer to a pivotal moment in human history, the potential discovery of extraterrestrial life. The implications of such a discovery would be profound, reshaping our understanding of our place in the universe and inspiring future generations to continue exploring the cosmos. In conclusion, the universe is teeming with potentially habitable planets, far more than the number of humans on Earth. This abundance opens a realm of exciting possibilities for the future of space exploration and our understanding of life beyond our planet. The discovery of nearby, Earth-sized exoplanets like Gliese 12b and Kepler 1649c within their stars' habitable zones is a testament to the progress we've made in our quest to find other worlds that could support life. These planets, with their potential for liquid water and stable climates, are prime candidates for further study and exploration. While the vast distances and current technological limitations pose significant challenges, each discovery brings us closer to answering the profound question of whether we are alone in the universe. The potential to find biosignatures or even direct evidence of extraterrestrial life on these distant worlds is a thrilling prospect that drives scientific innovation and fuels our collective imagination. As we continue to explore the cosmos, the abundance of habitable planets reminds us of the vastness and diversity of the universe. It inspires us to push the boundaries of our knowledge and technology, to dream big, and to keep searching for answers. The journey to uncover the secrets of these distant worlds is just beginning, and the possibilities are as boundless as the stars themselves.